Hi, this is Jeff Spencer, Math 120 instructor for the Community College of Denver, and this is the second part of the percentages lecture, which is section 8.1 in the old book and homework number 1. So in part 1, I covered all these examples. Remember, we have 3 different formulas that we're going to be basically, or that I apply frequently when I use any kind of percent. Either I'm computing a basic percent, proportion divided by a total times 100. But generally, if I'm given a percent and I want to apply it, I have to convert it to a decimal form and either multiply by the total to get my portion as the answer, or sometimes if I don't know the total and I'm given the portion, I take the portion divided by the decimal form and I get my total. The last part that we're going to cover is when we want to compute a percent increase or decrease. So an increase or decrease in the formula is computed by just doing a quick subtraction just to figure out how much something has changed. And then we're going to divide that by the original, sometimes called the reference amount. All right, so we're going to see this and then we multiply by 100 to convert it to a percent. So really we're kind of using a very similar kind of idea that we have a fraction times 100, multiplying by 100 to convert to a percent. But this time we have to understand where to put the correct numbers to get these answers. So the uses of this formula is like if we want to compute a change, a raw change as a percent, or checking like raise amounts, like, oh, I went from this pay to that pay, let's see what my raise amount was. So another example for this would be yesterday, and so you'll see this a lot in the news, the percent change of new reported cases for one state over the course of a week or a day or whatever like that. So I'm just doing from day to day here. Let's say yesterday Colorado reported 325 new cases of corona, while today they reported 285 new cases. Give the percent change to the nearest tenth of a percent. Well, first I have to actually compute the change, which is not shown in this formula, but it's pretty obvious that we got to do that subtraction. So there's 285 cases today. Let me pause this. I got to reboot this. So there's 285 cases today, and there were 325 cases yesterday, so that means that the number of cases decreased by 40. So it's a decrease of 40, and I'm going to represent that as a negative. So then a decrease divided by the original amount. So the original amount was 325, that was yesterday. So I divide that by 325, oops, divide by 325, change divided by the original amount. We started with 325, now we're down to 285. So I divide by the original amount, multiply by 100, and so divide by 325, multiply by 100, and that gives me, and it says round, give the percent change to the nearest tenth of a percent. So this is the answer as a percent. So to the nearest tenth, that means I look to the decimal to the right of it. It's a 0, so I'm going to keep this as a 3. So you can either write negative 12.3%, so, or you could say, or you could give it as a 12.3% decrease. Either one, negative or 12.3% decrease. All right. Then next, it says you make $12.50 per hour at your job, but next week you're getting a raise and will make $13. So in other words, you're getting a 50-cent raise. What was your percent raise to the nearest tenth? So once again, the change is the 50 cents. So I mean, I'm just going to show the subtraction just for the sake of doing this example. I made $13. That's the new amount minus the old amount, $12.50. Shows that I'm getting a 50% raise. Then I want to take that and divide it by the original pay that I was getting, $12.50. My raise was based off of that amount. And then I multiply it by 100. And it shows that I'm getting a 4% raise. So I'll show the math here. I was getting a 50% raise. My original pay was $12.50. I multiply that by 100, and it gives me 4% raise. Raise means increase, so that's implied there. All right, so remember that when you're doing this, you need to compute the increase or decrease and do that as a subtraction. I know that some people do this problem where they do 13 divided by 12.50, but then they don't know what to do next. And I'll show you here quickly, but this is not how I teach people how to do this problem. You have to understand that this 1.04, this is not part of the increase. The 1 represents the 100% that you used to get, and now you're getting 4% on top of that. And you have to know what you're doing if you do it that way. I don't recommend it, so please follow my formula and do it that way. Thanks, we'll see you next time.